Okay, so I think we get started. Okay, that would be very so now you saw the technologies doing very well and interacting in a more marvelous way with the body, and technologies failing very miserably. I wish I had some jokes to tell you about that, but I don't. So this is the part of the show that is a little bit more didactic. People who were invited here to this panel are not just people who are experts in their fields, but they also run labs and they have their own groups and collectives they're working with. And I just happen to be one. So let me introduce you to the ArtSci Salon. So this is the main question that we ask. What happens when we put artists and scientists in the same room? Do you think that they're going to fight?
Sure.
Do you think that they are going to ignore each other? Especially when one of them is a woman, actually.
No way, it's not.
Or are they going to talk and talk and talk without ever understanding each other? And they're just talking about each other's head. What do you think is happening? And this is another option, are they going to share language, skills, styles, and resources to achieve goals that benefit both sides? So in this case, the ArtSci Salon is not really a lab, but it's a collective of people. We took the challenge very seriously. So our main question is, how can we bridge differences in languages, view goals, and initiate dialogue, where many parties just find the right amount of interest to keep going and collaborate with each other. So we are a collective led by a scientist, Stephen Morris, who is here, an artist and curator, me, Roberta Buiani, and a bunch of other people, artists and scientists. We were inspired and encouraged by, and I should really credit him, Jim Rackstone, who many years ago, 20 years ago, he founded this Salon Technologies Festival, which was the first festival ever that dealt with the relationship between art and science. What are we doing? So we started really like in a classic way. So we started with a series of interdisciplinary talks, but then we decided to start putting together demonstrations and workshops. And we had one in January with internationally known Martha Menges on CRISPR-Cas9. But then we started doing exhibitions. This is an exhibition that happened in the territory in a gallery, the Red Hat Gallery. And then we thought, well, there's a lot of abandoned spaces here at the University of Toronto. They're underused and they're very dusty, so why don't we repopulate them? And we put art and science collaborations inside them. So we have this, the Cabinet Project. We have this, the Koffler building exhibition space with some illustrations from one of our guests. We have this, which is the FACT. An exhibition that was co-hosted with Martha Menges and Cultivamos Cultura from Portugal. But then the latest thing is we also want to take over spaces, and we want to remake the institution as not just a scientific institution, but also as a space where the public is intervening, is making it its own. And so yesterday we had the fabulous Margarita Pevere, who occupied the space of the Fields Institute, and she did a wonderful performance where she used the entire space of the Fields Institute's atrium. So if you're interested in getting involved, this is the ArtSci Salon. Check it out, and thank you.
I'm Jane Tingley. I'm an artist and a curator and a researcher. I work at the University of Waterloo. At Waterloo, I have two labs that I work at. The facility for, oh, just one second. The facility for fully interactive physio-digital spaces. And this is in collaboration with people in HCI and Fine Arts. It's basically comprised of a fabrication lab as well as a staging area. Sorry, I usually get nervous for the first 5 minutes of any presentation, and this one's exactly 5 minutes, so I'm going to be shaking. That's just my lot in life. So it's a place where human-computer interaction and new media art come together in research. And we're trying to research and invent the next generation of interactive paradigms for fully interactive physio-digital spaces. So in this facility, we explore and create what we call phygital objects, or physical digital environments where everything can be interactive or be displays with interactive content. The other lab that I have that I'm a co-director of, is the Stratford User Research and Gameful Experiences Lab, and this is at the Stratford School of Interaction Design and Business, which is our new name. And at Surge, it's a research space that includes a maker-like space called the Engage Lab, and as well a user testing facility where we have an observation space so that we can actually prototype interactive projects, artworks, game objects, and then we can test the UX for these objects. The facilities are currently getting built, and I think we'll have Surge up and running by the end of the summer, which is very exciting, and FIPS should be ready to go in 2019. So, for myself, my practice or my research focuses on the messy intersections of where two systems meet, specifically technological bodies and natural bodies. And they unpack, and I'm interested in how these systems intersect, unpack, and how they mediate each other to share experience. My goal is to create artworks that encourage embodied exploration and interaction, while also trying to understand the nature of how we engage with these systems, and how we come to both interpret and understand them. My background and training is in fine arts, so I'm deeply interested and invested in the visual metaphor, the visceral embodiment, and experiential aspects of my work, but I'm also deeply interested in the materiality of interaction, the ethics embodied in new technologies, and the power digital media artworks have in creating thought-provoking scenarios and experiences for critical reflection. So this piece here is an example of a project that I do. Just quickly, this is a responsive installation. This is more of a curated installation project that I would do where the objects articulate robotically by gently tapping the floor as you move throughout the space. I also do more interactive generative work, so this piece is Recollect. And the piece has it's 5 channels of sound, it has output and input. When the sound is also spatialized, and so when the body moves through the environment, they push the sounds throughout the space. Now this project reacts to the viewer in the same way we might react to the viewer. It has its own memories, its own life experiences. It gathers memories in the form of sound files. And these sound files are either kept in the long-term memory banks or the short-term memory banks. And when it responds to you, it gathers its life experiences. So this piece has been from New York to Dubai, and it has sounds from all of those, and that forms its sonic memory of its life. I also do interactive, or I guess performative robotic pieces. So this is an interactive system that the human host collaborates with. It's a cocktail-making robotic cocktail dress. It was designed for a festival in Vienna called Robo Exotica. And yeah. Okay, so this is the piece that I'm working on right now. It's something I'm the most invested in. I'll just play this little video. Doesn't seem like my video wants to play. Oh, it's frozen. Oh, here we go. Okay, so Anywhere is a distributed sculpture that essentially is the same sculpture that exists in 3 different places in the world. These sculptures do the exact same thing at the exact same time and allow people to interact with each other through the objects. So you can see here that we have different colors that are assigned to the different locations so that people are able to identify other human interactors. The primary research question for this work is how can we encourage embodied interactions between distributed interactions that do not rely on voice and vision. We've created a work that allows for distributed people to collaborate and work together in order to transform the works. The works allow for direct, individual, or collaborative interaction, vicarious interaction, so by observing, as well as passive viewing styles. So if you choose to engage with the work, we've developed a number of games. So Cindy Paremba, she's teaching the Digital Futures program at OCADU. She's designed a number of games and interactive scenarios that people have to engage with in order to transform the work. The different transformations bring you to different art states, and then of course they have their own unique interactive scenarios. And I'll leave it at that. Thank you very much.
Hi everyone, so check. I guess my lot in life is that I'm quite comfortable on stage, but I'm not used to spending only 5 minutes on stage, so I'm going to time myself. I also took a bit of a different approach. I took quite a maximalist approach to the slides, so I put every project ever on one slide. So I'm really happy to be here. So I've started this place called the Distributed Performance and Sensorial Immersion Lab at York University. Been doing a lot of public events as well as closed-door research with collaborative members of the York University and members of graduate members of York. I haven't been downtown doing stuff that is not performative in quite a while. I think that I was thinking about this, that maybe the last time I was downtown for an event that wasn't a performance was a month after I got here, and it was for this really nice Italian film called Il Giovanni Favoloso, or Leopardi, by the wonderful director Mario Martone. And I had a piece that was part of the soundtrack. I collaborated with the National Ballet School, a movement project. In terms of serendipity and intersections, those performers are wearing the same sensor band that Marco had on his right bicep during his performance, which is quite interesting. Working with a more modern dance context. If you happen to be passing to Ottawa in a couple months, I have a piece that's in a swamp, essentially around a pond, which is a series of evolving objects that listen and sound and react to their environment. So it's called the Genetically Sonified Organisms, or GSOs. And that work was workshopped within the laboratory context in collaboration with Kiran Raj, an undergrad student. I have some amazing undergrad students that I treat like graduate students, which is quite special. And so this work continues and is kind of blossoming out of this sort of larger arc of trajectory that really is around these issues of distributed agency, collective awareness, with a focus on the sonic and the haptic, and it continues. I'm probably close to 5 minutes. I'm over 5 minutes, sorry about that. I should mention that you might have noticed my associations were music, computational arts, and theater performance studies. I've done my duty to make sure that I'm associated with all those programs, so I'm here to steal all of your new graduate students and come to your place to work in the Dispersion lab. And I should mention that we have a PhD and MA and MSc program in digital media that's starting next year through computational arts and engineering. It's very much an art science thing, so come up to the lab and work with me. Thank you.
I'm an assistant professor in the Institute for Aerospace Studies at UT, and we work on combining machine learning control and robotics to make robots ultimately more capable. So just to give you an idea, these are the type of platforms we work with. The one at the bottom on the right, they are about this size, and then the top right is a few hundred meters wide. So it's quite a range of different flying vehicles, but also ground vehicles, from real cars to kind of more off-road vehicles. And to give you an idea, we work on the algorithms that, for example, make that happen. So as a human, you could never control 5 vehicles at the same time in such a synchronized way. So there are some feedback control algorithms that take the human input, which you see, and then command the vehicles to stay in the air and do this kind of coordinated motion.
That's incredible.
We have also collaborated with Cirque du Soleil. That was when I was still at ETH and working with Raphael and Andrea. And this was one of the performances. that was a trial, kind of a proof of concept, and the lampshades are the flying vehicles. And that would be usually music, but I thought this gets across the point.
That's incredible. Yeah, it does indeed.
We work on combining machine learning with robotics, and one reason is explained in this video. So here, this is again a demonstration. If you come to our lab, you can do it, where we turn a human-written motion into a vehicle motion. And if we do that with traditional methods, that's what happens. So the green line was not really on top of the red line. And so if we use some machine learning, we get much better performance. And so we invited many people in the lab to actually try this, and this gives you just an idea. So the techniques that we developed here are quite versatile. And so people can come to the lab and write on the tablet or their phone, and then see the vehicle fly. And this is just one of the research projects we work on, but it nicely demonstrates that improved performance using previous data to enable the robots to learn from experience. We also work on driving vehicles, and so this is actually an undergraduate team working on a self-driving car competition. The first competition is in May, and this is work, we got the car in October, and it's driving autonomously and doing the kind of competition tasks like following roads and avoiding obstacles and so on. And to give you a bit of a better sense what robots experience, we also did a long-term experiment, an off-road vehicle driving kind of every few days, the same route outside in Canada. And this is kind of the vision data that it collected and used to navigate. So you see, it ranges from light snow over really freezing rain, all the way to vegetation growth. And that's the challenge with the new applications of robotics. They really have to deal with a large range of different conditions, and it's really hard for us as engineers to pre-program to do that. And so I see, these are the robots today. Basically, they have complete knowledge of their own capabilities and the environment, do very simple tasks, are pre-programmed and are far away from humans. And this is where the largest growth in robotics happens right now. It's in the commercial and consumer robotics, where robots really support people, and that's where they have to be adaptive and deal with limited knowledge and do that successfully. And that's where I think machine learning comes in robotics, and will eventually enable robots to be more capable and more supportive. And I often like to compare it with computing. Like, in the 1920s, a computer was a person, and then we had the first industrial computers, and now everyone has that. And in robotics, we have manual car assembly. Now all the car assembly is usually automated, but what is kind of going here is one of the interesting questions in our field. Something to think about, and I think artists can give a lot of inspiration to answer that question. Yeah, and it's a very interdisciplinary team. We need to write code, but also make it happen on real platforms. So, yeah, these students come from various directions, and without them, I couldn't do that. Thanks.